Hello everyone. Today I'm going to discuss the topic that is binary tree. So in this video, I'll first discuss the binary tree, what is binary tree, explanation of the binary tree, and finally then its representation and how to represent it in a particular language, binary tree. So basically, I will present in C++ using class and in C using struct. Okay, so now let's move to the explanation of the video. So what is binary tree? So as the name suggests, it is a tree-like structure. As I have mentioned in this also, it is a hierarchical data structure, means it follow a hierarchy of something. Okay, so hierarchy of nodes basically. So this is a typical example of a binary tree. So I represent binary tree with the bt. So in this binary, as the name suggests, binary, so it every node in the tree will have exactly two nodes, or zero node or one node, maximum of two nodes basically. So this is a structure where this is a one node, I can name it as one. It has two nodes, and this one, the one on the left is known as left node, the one on the right is known as right node. So basically this is called left child, this is called right child. Similarly, we can further break down the hierarchy as left child, right child, left child, and further down. Okay. Now, if I go to above, then 2, 1, this is the parent of 2, basically. And similarly, this is the parent. If I go in the reverse order, if I go in the top-down approach, then they are children. In the up-down, they are parent. Okay. Now, top root. Now, top node of the binary tree is known as root. We generally call it root. These are children, and the node which are at the last level are known as leaf nodes. Means leaf node, this is the last level. After this there is no node, so this is the last level, and we call it a leaf node basically. Okay, now we can also think, we can also say that this is the I'm just in the terms of, so this is in terms of index 0th level, this is actually first level, and this is actually second level, and so on and further the goes on. Okay, now let's discuss about the types of binary trees. So we have a number of types of binary trees. Basically in general we have 5, we can make more, but these are the most used binary trees. So what is a full binary tree? The first is full binary tree. So full binary tree is basically a tree in which every node has either 0 node or 2 node, not one node, either 0 or 2. So if I make the structure, it will something look like this. Okay, so this is a full binary tree, as every node has two children. This has two, and last node has zero children, and this also has zero children. So basically this is nothing but a full binary tree. Now complete binary tree. So complete binary tree is slightly typical. So the complete binary states that all the levels are completely filled except the last level, and in the last level the node has to be filled from the left side. So let me draw an example. So suppose this is a tree. Okay, so let me fill the all the level. So in this, as I can see that suppose let's fill this level also. In this, all the level is filled. So basically this is a complete binary tree, but if I start a node from here, and this is also a complete binary tree, but if I put a node here, this is not a complete binary tree. Okay, but if I put a node here, this is a complete binary tree. All the levels are filled except the last level, and nodes in the last level has to be filled from the left side. Okay, so this is an example of a complete binary tree. Now the next one is perfect. So perfect binary tree means the binary tree whose last level is completely filled. Suppose this, so it is the last level and it is the completely filled, so it is a perfect binary tree. Now the balanced binary tree, its definition says that it can have a height, the height which is a depth. Suppose this is a binary tree, so its maximum depth is 1 2 3 4, basically a height of 4. So in the balanced binary tree, I can have a max height of log of n, where n is number of nodes in binary tree. So basically balanced tree definition is that it can have a maximum height of log n, where n is the number of nodes in binary tree. Okay. Now this last one is degenerate tree. So degenerate tree is basically a straight tree or skew tree. So basically if I make a structure like this means a straight structure. This linear structure in a sense. So basically in a, if it is also generally known as linked list because it looks like a linked list, because we can only move forward in the tree also and linked list also. This is nothing but a degenerate binary tree. Okay, now the next topic, that representation. Okay, so now the representation of the binary tree. So okay, so representation is this. Okay, so now what I can do is I can represent using the struct in the C language, and in C++ I can use the class based representation. So in C language, I will make a struct node. So basically, a struct, with the help of struct, I can make a complex structure, complex variable. I can say basically a combination of different data types is a struct. Okay. So int data struct node left right. This is nothing but it is filling our node values initially. Okay. So if I make a structure like this, it will look something like this. I have this type of structure. The middle one contains data, and this contains the same structure and point. These are left pointer, this is right pointer, and it is pointing to something, a same structure like this, and it is containing the values basically. And further this goes on, this again represent to some same values. Okay, and similarly a class based, the only difference between this is class based approach in C++ provide more features like inheritance, encapsulation. We can do more in these things basically. Okay, so this is also the same, but we can declare private. This provides security and many things else. So public class node, this is the class name, and if we want to declare it in the main, I can simply use node star. Suppose it is a root, and with the using new keyword, because it will initialize memory in the heap, new and node. Since I'm using parameterized constructor, I have to provide the value, suppose 5. So what it will do, it will create a node like structure, and 5 will be its value, and its left will have null, and its right will have null. So it will create a, this code will create a structure like this with the help of this class, because it is saying that when I initially initialize any this class, the data I am providing will be this, and its left and right pointer will point to null, which I can change later using different methods. Okay, so let me give the example of how to do this. So what I will do, suppose I make another node of left, which new, and node, suppose I provide a value of 10, and suppose right, let's call it right, new node, and suppose let's call it 20. Okay, so what I'll do after this, suppose this is root. So what I'll do, root to the left, I'll put left is coming from class, and this left, suppose no, let's rename it left node, and लगा देते हैं left node. Okay, so left n, so basically root का left now will point towards left n. So basically it will create a structure like 5, and it is pointing to a same structure like this, which is 10. Currently it is right is pointing to null because I have not initialized the right, and again it is null, and it is also null. Now if I write this code in the editor, that root ka right is equals to right node. So what the code will do, it will remove the null from here, and it will place this node 20, and its left and right will again point to null. So this is basically a typical primary use of the binary tree. And in the next video I'll discuss about how to traverse the binary tree using techniques of DFS and BFS and some strange traversals. Okay.